Assalamualaikum and hi, I am Muhammad Nishar Baisami and I will present about strength performance of concrete using cold bottom ash as coarse and fine aggregate of 100% replacement. Okay, for the content, I will present about the introduction, problem statement, research objective, scope of research, significance of research, literature review, methodology, result and discussion, and last is my conclusion. Okay, for introduction, we know that coal bottom ash is a waste from power plant and it's a coarse material that falls at the bottom of the furnace in the latest lash of thermal power plant. It consists of non-conventional material and is the residual part from the incineration of household and similar waste. The first picture is the example of the coal bottom ash, and for the second picture is the thermal power plant. Okay, for the next slide, for the problem statement, there are too much waste occur of the coal bottom ash, which are 18,000 ton per day for one thermal power plant, and they need to handle this material by and dispose them at the pond and the landfill. This will increase the disposal cost if the area is full and they need to construct another new area at another place. Also, they will increase the transportation cost to transfer or dispose the material at the another landfill and the new pond area. Last is the depletion of natural resources, which the amount of fine and coarse aggregate keep decreasing because the number of usage is more increasing and more bigger. Okay, next is, okay, for my research objective, first is to study the physical and mechanical properties of concrete mixture with and without the coal bottom ash. Second, to investigate the strength performance of concrete, and last is to determine the durability of lightweight concrete. Next, for scope of research, the material that I use is waste coal from power plant, and the type of material is coal bottom ash. My focusing experiment is full replacement of fine and coarse aggregate, and the size particle that I will use for fine aggregate is 2.35 mm, and the coarse aggregate is between 5 until 10 mm, and the test that I will conduct is compressive test, pressure test, water absorption, and density test, and last is chloride penetration test, and this test I will do at the Casa Lab UMP. My significance of research is to reduce the landfill and pond of the use of coal bottom ash disposal. Second is to save costs for disposal and construction of disposal area. And last is to save the natural resources from depletion. Next is, for my literature review, I will explain about the top 2 research that I found, which first is improved chloride resistance of high strength concrete amended with coal bottom ash for internal cooling. But my finding is the high strength concrete with lightweight aggregate. The high cement content was required to balance the degradation of mechanical properties and durability induced by the lightweight aggregate. And my second is strength properties of untreated coal bottom ash as cement replacement. And my finding is the concrete cube with 25% of coal bottom ash produce the highest compression strength compared to another. Okay, for my methodology, the main purpose of this research are to study the strength, performance, and durability of concrete with 100% of coal bottom ash replacement according to ASTM standard. And the coal bottom ash sample was collected at Tanjung Beam Power Plant, Kukup, Johor. The sample is crushed and sieved for required size for fine and coarse size. And the test that I will done is compressive test, pressure test, water absorption and density test, chloride penetration test, and all of these tests I will done at Casa Lab UMP. For my mixed proportion, I will have 5, but I will focus on 2, which is control and 100% of coarse bottom ash and 100 of fine bottom ash replacement. Okay, for the flowchart, first is preparing raw material which is for the core bottom edge. Next is mold or formwork preparation for the cube and the beam, and then casting. And next is curing. I will use the water curing, and after 28 days I will do the testing. Okay, for the compressive test, I will follow the ASTM C39, the standard of compressive test for the cube, and for the flexural test is ASTM C78, the standard for flexural test for 3-pin for beam, and the size for the compressive test is 200 times 100 times 100 millimeter, and the cube is 100 times 100 times 500 millimeter. The third test is water absorption test. The water absorption by concrete is a measurable of the concrete total reachable pore volume. High water absorption implies a high porosity. I will follow the ASTM D570 water absorption 24-hour or equilibrium. It's mentioned that water absorption is used to determine the amount of water absorbed under specified conditions at the step below. For density test, this test is to cover the determination of the density of freshly mixed concrete and give formula for calculating the unit weight, yield or relative yield, cement content and air content of the concrete. By referring the ASTM C138, the standard test method for density, unit weight, yield and air content gravimetric of concrete, which determine the density of fresh mixed concrete and formulaic data. And the last test that I will do is the chloride penetration test. This test is to determine the concrete surface defect and compressive strength after immersion into the chloride solution. By referring ASTM C1543-10A, standard test method for determining the penetration of chloride ion into concrete by pounding, which have withdrawn at 2019, which determine the penetration of chloride ion into the concrete from a sodium chloride solution. Now I will explain about result and discussion. The compressive strength show that the control have a steady increasing trend, and CBA replacement show also a steady increase, but they had a little fall at 28 days, and the total highest of the strength shows that the CBA have slightly higher strength than control. For the flexural test, it shows that the control highest value is on 56 day, it is 3.87, while the CBA replacement of 100% shows their highest value is 6.806 on 56 day, which are 22 times than the control means. For my third data is water absorption test. The data shows that the water absorption ratio of core bottom edge is higher than control mix. It's proof that the core bottom edge have more moisture content than control mix, which the CBA absorb more water than natural resources. Next is for the density test. The density of control mix is 15% higher than core bottom edge replacement. The increasing of density value is cause of hydration process during casting, maybe during casting process. And according to ASTM C13, yield is proof that the volume of the concrete produced from the mixture material of the product show the difference. Last is for my durability or chloride penetration test. Show that the data show the compressive strength of the cube after penetration test is almost same, but for 0% is lower than CBA replacement, and it keep decreasing. This data show it may occur due to the surround control or compression of cube while cause pore in the cube. And the second is for the weight change. The weight of concrete during immerse curing age in 5% of NaCl solution show slightly change in CBA replacement, but the control mix show 13% average of weight loss, and the weight loss due to the surface defect and water absorption ratio is that can be a factor effect of the weight loss also. In the conclusion, It revealed that the properties of physical and mechanical of coal bottom ash have almost same with natural resources behavior. The second is it noted that the replacement of coal bottom ash had recorded higher compressive and flexural strength. It proved that the pozzolana properties can be used as a replacement and it was developed effectively when changed curing ash. And the last one is the durability of concrete on 28 to 90 days show that the compressive strength of CBA replacement is slightly higher than the natural resources concrete. It concluded that the replacement of CBA had slightly effective positive result to the concrete. For my recommendation is to conduct more tests involved with bonding strength, bending strength and tensile strength. Second is a series of investigation on durability tests of co-bottom edge concrete such as porosity tests and various acid tests that should be conducted. And last is have a proper place for curing term of condition since the curing place are exposed to environment in terms of heat, rain and temperature changing. That's all. That's all from me. Thank you very much.